welcome to GitMap. It's time for the project. We are gonna do deep learning on image classification and we're gonna start convolutional neural network. I know it has been a while that you were waiting for a deep learning project and it's time to get it started. We're gonna present deep learning utilizing TensorFlow, deep learning utilizing PyTorch. Those are two platforms in order to do deep learning. For those who are new to data science area, I would recommend use TensorFlow because it's much easier to use. And for data scientists who want to do more research and do more debugging and needs more flexibility, I would recommend use PyTorch for implementing deep learning. Our project is gonna be image classification and we will use handwritten image dataset. This is the popular dataset and it is like a hello world to the programming to deep learning world. So it is base, and if you understand this programming in a good way, then it's gonna be a path for doing more complicated deep learning modeling. So let's get it started with image classification using convolutional neural network. We're gonna talk about image processing, specifically image classification on MNIST dataset. MNIST dataset is pretty popular dataset in image processing and it is called as a hello world for image processing. And most of the popular algorithms that came after, just simple deep learning have used MNIST in order to test the model. Just referring to deep learning, any neural network model that has more than 3 layers normally are called deep learning. And here specifically we're gonna work on convolutional neural network. We already have podcast in that regard, and also we're gonna have some lives with experts in this area for image processing. And here is the project for MNIST classification using TensorFlow and PyTorch. Before, let's do first thing first. Here we're gonna start by exploratory data analysis on MNIST dataset, which normally starts by visualizing data, understanding data, and doing more statistical analytics on dataset. We have 3 different notebooks. One is MNIST exploratory data analysis, the other one is classification using TensorFlow, and the last one is classification using PyTorch. So here the problem is identifying text in image. Our goal is building a neural network that can take these images and predict the digit in the image on test set. The steps that we're gonna follow in order to create convolutional neural network using Keras and PyTorch are as follows. We're going to import basic libraries, load, train, and test MNIST data, visualize dataset, build convolutional neural network model, define loss function and optimizer, train the model, and finally evaluate the model. We tried to implement exploratory data analysis using TensorFlow versus PyTorch in order to show you how these two deep learning frameworks, are different from each other. So utilizing, just before going deep, for MNIST dataset, we have training data and test data. Here we're gonna load and read training data from the folder. You can basically read that from the libraries that I'm pretty sure for PyTorch we have Torch Vision library. For TensorFlow, I downloaded that inside this MNIST folder and then I'm reading that from there. Okay, first I specified the path for the data set, and here I read the images of training set, testing set, which has features and labels. And you can see that we have 60,000 training images and 10,000 test images. And here you can see the visualization of those features versus the label, which is at the top as a title for that image. This lines of the code shows the number of the training features for each label, and you can see that we have about balanced number of the features for each label, meaning that like 10 different classes are almost balanced, not very uniform, because the number are not exactly the same, but still they have close number of the instances for each class. And then here is different types of the visualization, and then we move on to exploratory data analysis with PyTorch. One important thing about PyTorch is that it has data loader benefits, as that we can load the data inside the batches, and this is gonna fasten the reading data set inside the system. So at each iteration it tries to read, for example, if we have batch 20, it's gonna read 20 pictures at each iteration and move to the next one. And then we have epochs, of course. Do not confuse this iteration and the batch reading with the epochs, because they have different meaning. So this data loaders happens due to limited availability of the memory space. It is a technique that called batching, and this batching basically simply accesses the record from such a huge data set inside the batches and not all of the data at once. For example, let's suppose we have 1,000 reads in the data set and we want to apply batching on this data set. If we set the batch size to 200, our model will be first trained on first set of 200 read in first iteration, and then on the second 200, and forward until it takes 5 different iterations. For epoch, when we have every read of every data set through the network, then it is called one epoch. Those are differences between batches and iteration and epoch. Okay, we have here the bean count for different labels, and you can see that this line of the code is exactly similar to this line of the code here, which gives you count of the labels and count of the different classes. And then here we are trying to get the shape of one image. You can see that 21, 28, 28, which is 28 by 28 pixel grayscale, because we have one here. If we had colorful image, this could be 3, and then 20 because we have, of course, 20 images in batch. And finally, you can see that if we want to just visualize one batch, it looks like this with the labels. And then this is again, one test data batch is a tensor of shape 1000, 120, 28, meaning that 1000 sample of 28 by 28 pixels are in grayscale. And this is 1000 because we are considering all of the batch. Each batch is 20, and in 5 iterations it's going to be 1000. And one more thing is I am trying to mention that we have different type of the data holder. One is, scalar, which is just the constant numbers, and then we have arrays, which is one-dimensional, and then we have matrix, which is two-dimensional, and finally we have tensors, which are multi-dimensional data holders. And here we're gonna use tensors, either for TensorFlow or PyTorch. Okay, let's go to classification by TensorFlow. Keras is high-level API of TensorFlow. So TensorFlow is implemented in Keras, and you can use Keras in order to develop your first neural network model. It is a declarative program that tells you what, but doesn't tell you how. And in symbolic language, which TensorFlow is in symbolic language, you need to define the graph and then you need to compile it. And static language means that getting defined and then gets to run. However, in PyTorch, it is open source deep learning that is developed for with flexible framework and is developed for researchers to do more research, and it is really simple and similar to Python and NumPy. That's why PyTorch is pretty popular, and it is developed by Facebook. Most of the PyTorch code are imperative language, which tells you what and tells you how, unlike TensorFlow, which doesn't tell you how. This one does tell you how. So you can easily debug PyTorch framework and see what's going on and what doesn't run correctly, and definitely fix that. Dynamic computation graph are built and rebuilt as necessary, and PyTorch uses Torch as a dynamic computation graph, so it is pretty flexible. Okay, for TensorFlow, we start by preparing the data, which starts by reading the data from that folder and getting train set, test set, trying to make sure that data are scaled, and then build, the graph, basically the architecture of the model using TensorFlow. Just note that this architecture is going to be similar to the architecture that we're going to have in PyTorch, so you can just compare them. And this is just a simple architecture for convolutional neural network. If you have any question about each layer, then definitely go to podcast, because that podcast explains clearly the layers, max pooling, flatten, and dense layers, and everything about convolutional neural network. Then we define the loss function, optimizer, and then finally we compile it, and then we train the model, fit the model, and finally we evaluate it. You can see that we have got 98.8% accuracy in classifying the images on test set. Now let's go to PyTorch classification. In PyTorch, as we already mentioned, we have data loaders, and we need to define the batch size, which indicates the number of the sample contained in each iteration for the worker, and it defines basically the number of the process that generates the batches in parallel. After we load data into the data loader and test loader, we're gonna build our model using the PyTorch. Net class is the main class that inherits from neural network.module class. Net has two methods. One is init and the other one is forward. So basically init is used to initialize everything that we need, and the forward method where we set the course of our model and use all layers that we defined in init function. When we use execute the code Basically, when we execute the code, init will be called and everything will be initialized. When we make the object of same class, then the forward method will be executed. And here you can see the structure of the model, which is similar to what we have seen in TensorFlow architecture. And then the same process, we define the loss function, optimizer. You can, play around this and change the atom, change the cross entropy loss. But for, multi-class classification, we need cross entropy. And then we're gonna train the model. After we train the model, this, the number of the epochs depends on you. You can increase that, you can decrease that. At each, as we mentioned, as we explained, epoch means that each sample goes to training set, and at each epoch, all of the samples goes to training, and then in next epoch, again, all of the samples goes to training in training set. And then that's how model learns and does the backpropagation. And finally, this is how we save the model. And then when we evaluate the model that is developed, trained, and tested on PyTorch, we get 99.98% accurate classification for the test set. This might be because of, just how accurately, how closely you can take care of the PyTorch training model compared to TensorFlow, which kind of looks like a black box. So if you are a researcher, PhD, and doing some computer science research, I would definitely suggest using PyTorch compared to TensorFlow, because that way you can debug it easily and figure out what's going on, how to save the model, how to use that, how to update parameters, how to build and rebuild models several times, and those all details that you can do with Python are implementable with PyTorch as well. Okay, thank you and talk to you soon.